Good morning all. In continuation with the previous video lecture, we'll discuss about another type of wavelength selectors, that is monochromators. So as you all know that the radiation source emits radiations of various frequencies. So it becomes necessary to select desired frequencies from the radiation source and reject the radiations of other frequencies. And this selection can be achieved by means of monochromators. And these monochromators are of two types. They are mainly of two types: prism monochromator and grating monochromator. And in this video lecture, we are going to discuss about these monochromators. Prism monochromators, it depends on the principle that the refractive index of materials is different for a radiation of different wavelengths. If a parallel beam of light, uh, if a parallel beam of radiation falls on a prism, uh, the radiation of two different, uh, the radiation of two different wavelengths will be bent through different angles. The isolation of two wavelengths is easy if there is a greater difference between the two angles. This is the principle of a prism monochromator. Here, in this picture, you could see light from the sources is made to fall on a parallel beam and made to fall on a prism after it is passed through the entrance slit and the mirror. The entrance slit is placed in such a way that it focuses the radiation to the mirror. The prism disperses the light and photons of different wavelengths are deflected at different angles. Okay. Uh, the light of any one wavelength can be selected by moving a slit across the focal plane. The required wavelength passes through the slit and the other wavelengths are blocked. Hence, in this prism monochromator, once when we change the position of exit slit, we can change the position of exit slit to select a particular wavelength, and we can also change the position of the prism. And these prisms are made of either glass or quartz. And the glass prisms are suitable for radiation, especially in the visible range, whereas the quartz prism uh, can be used for ultraviolet radiations also. Uh, so this is about a prism monochromator. Next comes the grating monochromator. You could see the diagram of a grating monochromator. If a prism in a prism monochromator is replaced by a grating, higher dispersion can be achieved. And this grating is generally a series of parallel straight lines cut into a plane surface. The dispersion by a grating follows the law of diffraction. Uh, it follows the following mathematical relation: n lambda is equal to d into sine I plus or minus sine theta, where n is the order of the grating, lambda wavelength of radiation, d distance between the grooves, I is the angle of incidence, and theta is the angle of dispersion. Okay. About what are the advantages of grating monochromator? These gratings can be made with materials like aluminum, which are not affected by moisture. On the other hand, this metal salt prism are subject to etching from atmospheric moisture. Next, it can be used for considerable wavelengths. Hope you have understood the monochromators construction and working. Thanks for watching.